Okay, so now we got to try to figure out her challenge. How many are we going to need for the number 100? How many rats would we need?
Well, the highest. So I think it has to do with 100 in binary. That's the highest number you can make.
All right.
So that would be, let's see, the highest power of 2 would be 64. So it would go 1.
So 1 has a 64. Okay.
And you got in the 32 place you got a 1.
In the 32 place we got a 1. And what are we up to so far now?
96.
96.
So
okay.
0.
0 in the 16.
0 in the 8.
0 in the 8.
1 in the 4. And then 0 in the rest of them.
Okay. So how many is that?
1, 2, 3, 4, 5, 6, 7.
So we needed 7.
7 rats.
We need 7 rats to write out 100.
And we only needed 3 more to write out 1,000.
Yeah,
So
and the amazing thing
they
is...
grow pretty quickly.
Well, because they get a lot bigger.
Yeah, they do grow pretty quickly. So it's a little bit of a surprise that we only need 3 more. So you guessed 7, so good job. The problem is with a million, with her challenge on a million.
How do you write a million in binary?
So we would have to figure out how to write a million in binary.
We don't know what the closest power.
But
yeah.
But if we could maybe solve, so writing it all out is going to be tricky. But maybe there's some additional insight we could have here, rather than writing it out explicitly. Maybe there's another idea.
Well, with 100 rats, well, you needed 7 for 100.
Yeah.
And 100 times 10,000 is a million.
Okay.
But I don't think you would need...
You don't need to multiply by 10,000, that's for sure, because 100 times 10 is 1,000. You don't need 70 rats for 1,000.
Okay.
I mean, maybe we could look at 10 bottles and see how many rats we need.
Okay. Just for this is an idea. All right. So 10. 10. I bet you can write in binary.
10 is
1,
1
0, 1,
Yep.
0.
1, 0, 1, 0. So that's 4 rats.
Okay. So we got 1, 8. No 4s. 1, 2, and a 1. So for 10 we need 4.
4, 7. At 1,000 you've got 10.
Uh-huh.
So first time you multiply by 10, you seem to be adding 3.
Oh, okay. So there's an interesting pattern. When you multiply by 10, you seem to be adding 3.
So it means you'd be adding 9 more.
Okay.
Maybe 19.
If that pattern continues, maybe we would need 19. Okay? Well, we don't know for sure.
But that's our guess.
Yeah, but maybe,
Like 1 bottle also is just 1 rat. That's 3 down from here.
Yeah, that's true.
Yeah, so it seems like the pattern would continue because 1 plus 3 is 4.
That's true. So it does seem like there's a pattern, but we don't really know why that pattern's there.
Yeah.
That's the tricky thing. So we don't know if it continues or not. But if we could find a relationship between 7, the number 7 here, and 100, the number 4 and 8, maybe we would be able to find the same. And we know it was, what, 10 was the 1,000, right?
Mm-hmm.
And we know powers of 2 are involved somehow.
Powers of 2.
Those numbers don't seem to have anything to do with powers of 2. I mean,
Not right away, they don't seem to.
you can't really relate them to powers of 2. I mean, you could do...
Well, we got 4
4 is a power of 2.
with 4 related to 10 somehow, 7 related to 100 somehow, and 10 related to 1,000 somehow.
How?
Who would it relate? Powers of 2. It doesn't. The nearest power of 2 is 8 to 7.
Yeah, that's right. That's right. What's the nearest power of 2 to 100?
That would be 128.
Okay. Which is what?
Which is 2 to the 7.
Okay.
Huh.
What about 10? Now the nearest power of 2 to 10 is in fact 8, but what about the 4?
Well, the nearest power of 10, a power of 2 above it is 2 to the 4.
Ah, okay. What about 1,000?
1024, which would be 2 to the 10.
Haha.
Well, we need to find the nearest power of 2 above 1,000,000.
Yeah, so how are we going to figure that out? The nearest power of 2 above 1,000,000.
Well, 2 to the 10 is 1024.
Uh-huh.
That's about 1,000, so squaring that would get you close to 1,000,000.
So what would squaring that be?
2 to the 20.
2 to the 20.
So around
But it-
20.
Around 20, maybe 19.
Oh yeah, less than.
Yeah, we'd have to just compute. And I think it's going to turn out, without computing it, I think it's going to turn out to be 20.
Cool.
But we'd have to compute. Maybe 2 to the 19th is bigger than 1,000,000. But I don't think so, because 2 to the 10th is only barely bigger than 1,000.
Yeah.
Right? So it's a cool problem.
Yeah.
It's a cool problem. By the way, that means if we played this card game again here, for all the numbers up to 1,000,000, looks like we would need 20 cards.
20 cards.
Alright,
Alright.
it's cool.
All right. Good job, guys.